Hey guys, and welcome to our data structures and algorithms tutorial series. Today we are going to be looking into the two most common searching algorithms, which are linear search and binary search. So what we are going to be doing here is not just theoretical, but we are also going to be writing some code. And in terms of the programming language that we are going to be using, we are going to be using Python. So without wasting much of the time, let's get started. But firstly, what we are going to be looking into is linear search. So in linear search, what we attempt to do is to check if an element exists in a list or it doesn't exist in a list. So I have a list that I have in here, and let's say I want to look for the element 7. How am I going to look for that element in that list? Well, in linear search, what you do is you check for the first element to see if it is what you are looking for. If it is not, you go to the next element and check if it is what you are looking for. If it is not, you also go to the next element until you find what you are looking for. Right, so that's it. Nothing much complicated. So let's start writing some code here and actually get to demonstrate what I've been talking about. So I'm going to define a function here and I'm going to name it linear search. So what this function is going to do is going to take two parameters. One, it is the list, and then the second parameter is the target. The target is what we are looking for. So we're going to have a list and a target. Remember what I said. We have to look through we have to look at each element and see it is what we are looking for. So here we are going to loop through the whole list and checking if the element in the current position we are is what we are looking for. So we are going to have 4x in range of the length of the list that we would have passed into here. So when we are looping through the list, we have to check if the element at the current position we are in the list is equal to the target that we are looking for. If it is, then we return the index to indicate that the element we are looking for is at this position. So here we are going to do if the target is equal to the current position we are at the list. If it is equal, we have to put some double equal sign in here, not just one. And then we are going to return x. That means x is the index at which the element exists. If the element doesn't exist in this list, we are going to return -1. That means if we ever hit this line, then it means we are not going to ever get to this point where we are going to return -1, because when we hit the return statement, our function is going to terminate and then just return what we have returned. So if we do not reach this line, then we are going to be reaching the line where we have returned -1. That means the element we are looking for is not in the list. So let's test out our function to see if it is working. So we are going to be having a result is equal to linear search, and let me grab copy this list I have at the top and say a is equals to not a, sorry, but something meaningful numbers equals to this. And here what we are going to be doing is we have to pass the list, which is numbers, and then our target, which we are looking for, let's say 7, right? So our function returns something. That means result at any given point, here's something that is meaningful, something that we can with something that we can make use of. So if result is not equal to -1, then we can print element found at position, not literally position, but index at the index that we would have said. And then else, if it doesn't exist, then we just say print element not found. So let's test this to see if it is working. So I'm going to run this. Sorry, I got this somewhere here. Right. So let's run this. See, element found at index 3. We are looking for 7, right? So this is index 0, index 1, index 2, and index 3. Let's say we are looking for the element 10, right? And if I run this again, you see element found at index 9, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's search for an element, probably 76, and see what happens. I run element not found. So that has been it for linear search. Nothing much more complicated. It is as simple as this. So next, let's jump into looking into our binary search. In binary search, we're going to be looking into it in 2 ways. We're going to have our first solution being an iterative solution, and then our second solution being a recursive search. So that means we are going to be using recursion. So let's jump into our iterative solution. Okay. So here, let's go on to linear search first. Here you see the list that we are using here is not sorted, right? But in binary search, our list should be sorted. That's rule number 1. So when I start explaining about this, you'll find the importance of how it is useful to have your list sorted in binary search. Otherwise, you're going to have results which are not reliable. Okay, so let's say I have a list that I have here and I want to search for the element 8 using binary search. So what I'm going to do is I'm going to find the midpoint of that list and check if it is what I am looking for. So here, if you find the midpoint of this list, we see that the midpoint is here and the midpoint is 6, but we are looking for the element 8. Well, 6 is not what we are looking for. So then what are we going to do next? We compare 6 and 8. We check if the midpoint is less than the target or if it is greater than the target, right? So then we see that the midpoint is actually less than the target we are looking for. That means if it is less, whatever we are going to be looking for, it implies that it is to the right because our list is sorted, right? So whatever which is greater than 6 is to the right. So we discard whatever which is at 6 and what going to the left of it, and we have a new list starting from the next element from the midpoint going to the last element of our list. So we remain with a list like this. Now, what are we going to do? We do what we did at first, look for the midpoint and check if it is what we are looking for. Check for the midpoint is 9. So is the midpoint value, is the value at the midpoint what we are looking for? It is not. We compare these two values. So is 9 greater than 8 or it is less? So 9 is greater than 8. That means what we are looking for is to the left of the list, because whatever is to the right of the list is greater than 9, and whatever which is to the left of the list is less than 9. So we discard whatever is to the right, right? That means we are left with a list like this, where we have one element, our element is 8. If we were to find the midpoint of this, we just remain it here. So is it what we are looking for? Yes, it is what we are looking for. And then we return true. That means we have found what we are looking for. As simple as that. Nothing much complicated. So let's dive into writing some code and see how it works. So I'm going to define a function in here, and I'm going to call the function binary search. So this function, like the function we had in our linear search, is going to take a list and it is going to take a target. So here, what we do is, for us to get the midpoint of the list, we should be knowing the the first starting point of the list and the ending point of the list. So we are going to be having the starting point of the list being, when we are going to call it left, and we're going to give it 0. That means at index what? 0. Then the ending point of the list, we are going to call it right, and we are going to give it the index, the last index in the list. That means the length of the list, and we are going to subtract 1 from there, right? So these lines can actually be simplified into one line, which I'm going to do here, such that it makes our code much more clean and probably readable in my own opinion. So we're going to be having left, right being equal to 0, and we're going to say the length of the list minus 1. Right? So what we had here, like these lines I'm highlighting, is equivalent to this one. Right? So we're going to get rid of these lines. Right? Then the next is, the thing what we are going to do is, remember what we said. The list should be sorted. So we are going to have a while loop that keeps on checking if whatever is at the left is less than whatever is right, like those values. So we're going to say y left is less than or equal to right. And then we are going to find the midpoint. So let's say the midpoint, right? So to find the midpoint, we're going to add the starting point, the index at the starting point, and then the index at the last, which is the ending point, and then we divide those by 2, and we round it down, so that, let's say we have 7 items, right, and we are looking for the midpoint. We're going to say 7 divided by 2, and then we got 3.5. Do we really have an index called 3.5, or from 3 we go to 4? So what we have to do is we are going to round it down, and we are going to say left plus sorry, we're going to say left plus right. We read this in brackets, and then we are going to put these 2 division signs, which means this is the flow division operator, which rounds whatever we, that means whatever we have is going to be rounded down. Even if we get a 3.9, like the normal, to round it the normal way, we get 4, but here it is the flow division operator, so 3.9 will be rounded to 3. So here we check if the target is equal to item which is at the midpoint. That is, if the target is equal to the list, and then at the position we have the midpoint, then we are going to return the midpoint, right? That means this condition implies that we have found what we are looking for, because we are saying we have found the index of the midpoint, right? So now we have to check if the element at the midpoint is what we are looking for. If it is what we are looking for, then we return the midpoint, and then that means we have found what we are looking for. Here, to simplify the things, we can, okay, let's leave it like that, midpoint, and then we go on to the next. So if we're going to check if the target, let's say we didn't find what we were looking for, right? So we're going to check if the target is less than the element at the midpoint. If it is less than the element at the midpoint, what are we going to do? We're going to say right is equal to midpoint minus 1. So what am I really talking about? That means is here, our target, right, here was 8, and the element at the midpoint was 6. And we're saying, is the target really what we are saying? Okay, let me first write some code in here, right, so that we actually have it to make sense much more other than to make things complicated here. And then we are going to do left is equal to the midpoint plus 1. So let's get back to the first condition had. So what we had here was we had 8. So is 8 less than 6 or it is greater than 6? That means 8 is greater than 6. So what did we add to here? We had to start from here going here. So then that means left is the starting point, right? So here we are checking if the target is less than the midpoint. This condition doesn't hold true for 8 and 6. So we come here and say left is equal to the midpoint plus 1, which means our starting point is now at 8 here. We have said the midpoint plus 1, which is what the index that we have moved, and we didn't change the ending point of the list. But now let's look at here. When we had the midpoint being 9, that means the target was less than what we were looking for. Then we had to get rid of whatever which was here, which means we had to say the right of this list is going to be at the midpoint here minus 1, which means whatever is to the left, which is from 0 up to the midpoint minus 1 here, the index. So after this is how our iterative solution to solving this problem of this binary search is. So now let's test out and see if it is actually working. So we are going to be having result equals to binary search, and we are going to be passing a list. Let me take the list I added first here, and then I'm going to say numbers is equal to this list, and we are going to take listed numbers and then pass our target. Let's say the target that we are looking for was 8. So at this point in time, what we are looking for was to check if the element is exists in the list, right? So what if we don't even went on to reach this line? Then we have to have a condition here at the bottom whereby we return -1. So our index is always start at 0 going up. So if we have an index being -1, then that means we didn't find what we are looking for. So now if the result is not equal to -1, that then we print element found at index, and then we just say this result. Otherwise we print element not found. Element not found. So let's test and see if it is actually running. So element found at index 3. We are looking for here. We are looking for 8. That means 0, 1, 2, 3. And let's say we're looking for element 10, and let's run this again and see what we get. Element found at index 5. That's 0, 1, 2, 3, 4, 5. Now let's search for something which is not in this list, like 76, and see what we get. Element not found. So that has been it for the solution. You are doing binary search using an iterative method, and now let's move on to a solution whereby we are going to be implementing recursion, which is a recursive solution to binary search. So here I'm going to define a function, and I'm going to call it recursive binary search. So as usual, our function is going to take 2 parameters, which is a list and a target, right? So what are we going to be doing here? We are going to be doing the same concept that we had here, like looking for the midpoint and checking if it is less than or greater than what we are looking for, and then we do it accordingly. Like If it is less than what we are looking for, then we discard whatever is on the left and continue with whatever is on the right. So here, what we are going to do is first we are going to check if the list is empty. If the list is actually empty, then we return false. That means we did not find what we were looking for. That means by using this method of len on this object of list, that means it returns, if we have one item in the list, it's going to return 1. If we have 2 items in the list, it's going to return 2. If we do not have anything in the list, it's going to return 0. So after this, what are we going to do? We're going to find the midpoint. And how are we going to be finding the midpoint, right? So we're going to look at the length of this list and then do our float division operator. So remember, we have on every list that we have a starting point and then we have an ending point. So in each list, the starting index is always 0. So if we say 0 plus whatever we have, that number doesn't change. So here that's the reason why we have omitted saying the first of the list plus the length of that, and then we find the float division. Then we do the float division operator to see, to check the midpoint. So now we say if the elements are at the midpoint, we check to see if it is what we are looking for. If it is what we are looking for, we return true. Then what are we going to do? We are going now to check if the element we are looking for is actually to the right or to the left of the midpoint, right? That means if it is greater than or less than what we are looking for. So we're going to do if the element at the midpoint is less than the target, right? What we are going to do here, let me first write this and then I will explain what this means. So we're going to be doing return the recursive why does it don't want to copy it here, there. And you are going to pass it the list, which is from the midpoint plus to the end of this, and our target remains the same. Our target remains the same. Otherwise, we are going to do the opposite of this. That means we're going to do from here to the midpoint, and our target remains the same. Right. So what we did here, let's take a closer look. If the element at the midpoint is less than what we are looking for, we are going to call this function again. So when we call this function again, it means we are calling this function inside of this function, right? That means we are going to repeat this function again. So, but when we are repeating this function again, we are calling this function again to run for the second time, we are going to pass it another list, right? And this list is going to start from the midpoint plus 1, right? Like what we did in our iterative solution. That means if it is less than what we are looking for, right? If the element is less than what we are looking for, then means what we are looking for is to the right, right? Then it means we are going to say the starting point of the list is from the midpoint plus 1, and then we put this colony, and then we just left it like that. So in Python, if we don't put anything at the end of it after this colony, then it means what value is going to be taken here is the end of the list. That means the index at the end of that list is what is going to be taken, right? And then our target remains the same. And then if it is not less than what we are looking for, we are going to also call this function again. And we're going to pass it another parameter. And then here, firstly, we did not specify anything here. That means it's going to start at the very beginning of the list, and then put a colon, and then we pass the end of the list, which is at the midpoint, and our target remains the same. Right. So a quick advice here on these lines. What we did here is was implementing a recursion. Recursion gets to be, most people find it very challenging and what. So if you do not understand it, then just stick to the iterative solution. But if you understand it, then that's cool with you. You can use that one and continue to do whatever that you will be doing, right? So now let's actually have to check if what we did actually works, right? So here I'll first correct this spelling error that I had here, that is binary. Sorry, is binary, and here it should be binary, right? Should be recursive, not recessive. And we have to put a C here, and also I have to put a C here. That means recursive binary search. Well, thanks to PyCharm for noting those spelling errors. Now, let me go into our iterative solution and just grab these two lines and come with them over here. So we have our list, which is here, which is numbers, which is 2, 5, 6, 8, 9, 10, right? So our list, is it sorted or not? It is sorted, right? That's rule number 1 in binary search. Your list should always be sorted. So what we are going, so the result we are going to be having here is actually reliable. Now let's do result, and we call this function, and let's check for the element what? For the element 8. So if result is equal to true, then it means we have actually found what we are looking for. But if it is not true, then if it is false, then it means we did not find what we were looking for, and we ended up having an empty list. So if result is equal to true, then it means we can actually do, but we can simplify this. We can just say if result, in Python we know that we are checking for a boolean. That means if result, then we actually print element found. Element found. Otherwise, if it is false, we are going to print element not found. And that is it. Let's actually print this and see if it is running. We have element found, right? So let's check for probably the element 9 and run this again and see if it is element found. So let's check for another item, probably 76. I don't know where I'm getting that number from my head, but anyways, element not found. That means 76 does not exist in this list. So that has been it for the recursive solution to binary search. So that has been it, guys, for this video. And if you find it helpful, please consider subscribing to the channel, liking the video, and I'll see you in another YouTube video.